Welcome to example number 2 of topic 7 of C234 mechanics of deformable bodies. We have here the plate shown as is fastened to the fixed member by 5 10 mm diameter rivets. Compute the value of loads P so that the average shearing stress and any rivet does not exceed 70 megapascal. So based on our previous discussion in example number 1, since the rivets are simply reckoned from the center of our shaft, thus, there is no need for us to compute for the location of our center of gravity. However, in this example number 2, we need to follow these following steps so that we can compute for the value of P that will not go beyond the allowable shearing stress of 70 MPa. First is, we need to draw the XY axis. Secondly is, we need to take into account the statics of rigid bodies formula in solving the coordinates of our center of gravity. So we need to locate for the x and y coordinates of our center of gravity. That means we need to use this formula, which is area total times the x coordinate equals to the summation of the area times the distance. And also it could also be area total times y, the y coordinate equals to the summation of the area times the distance. What do we mean by distance x and distance y? So these two is simply the distance from the center of gravity of a certain polygon to the axis it is reckoned. So what do we mean by this? If we recon this in this axis, and we have a rivet here, and we all know that there is an area in between our rivet which is in the form of triangle. Thus, we all know that the center of gravity of our triangle is simply 1/3 of its base if it is reckoned from 1/3 of its height, which if it is reckoned from the base, and 2/3 of its height if it is reckoned from the apex, and this is the base. So this is simply the location of our center of gravity of this triangle. And what we mean by x here is simply from the axis it is reckoned to the center of gravity or centroid of this triangle. So that is simply the x. And same for the y also. And the third step for this one, let me erase this. For the third step, we need to solve for the area total, and that is the area bounded by inside our rivets. And we need to take note that in order for us to solve for the x coordinate or the y coordinate, we need to further broken down that total area into areas bounded by the rivets. For example, at this example, the area total for this one is simply this one, and for this area, that is simply this one. For the fourth step for this one is to simply solve for the distance of our rivets to the location of our center of gravity. So if we can locate the center of gravity of this problem, then we need to solve for the r. So this is simply from the rivet to the center of gravity. So we can just simply see this one if we solve this problem. And for the fifth step is to compute for the polar moment of inertia, which is simply the J. And in your statics subject, the formula for the polar moment of inertia is simply the summation of the area of our rivets times the distance, and this distance square, and this distance is far different from this one because this distance is reckoned from the center of our gravity of all the rivets to the location of one rivet. So it's simply this one. And right now, for us to solve for the load P, we need first to follow step 1. For step 1, we need to draw for the y-axis. This is our y-axis. And for our x-axis, so this is our x-axis. And now next step is we need to locate for the center of gravity of our the coordinates of our center of gravity. So if you look into the diagram shown in the screen, from our x-axis we both have the same locations of our rivets, 80 mm below and above, 40 mm below and above. So we can simply assume that for the y coordinate of our center of gravity, that is simply along our x-axis. So what we can do now is to simply assume the location of our x coordinate of our center of gravity. So I can just simply assume that if we draw a line here, so this means that this is the location of our center of gravity, and this is simply x sub g. And for us to solve for x sub g, we need to use this formula. And for this formula, that is simply